Hello, what's up guys? I'm Swastyastu. Assalamualaikum Warahmatullahi Wabarakatuh. Syallom, Namo Budaya, and good to see you all. And let me introduce myself. I'm Imade Shanti, and my code is 23055310633, and our lecturer is Professor Dr. Chokodo Gede Tirtan India STMTMN. And in this material we have metallurgy with the code TM2301. I'm from Mechanical Engineering Technical Faculty Udayana University. So in this presentation I take my reference from Metallurgy for Non-Metallurgy 2nd edition, edited by Arthur Sheridan. So now we have the chapter chopping with the corrosion. They have 3 sub-chapters. The first is mechanism of corrosion, forms of corrosion, corrosion prevention or mitigation. So the first, chopping with corrosion, the word corrode is derived from the Latin corrodere, which means to gnaw away. While corrosion can occur in many different forms, it is most generally defined as a chemical or electrochemical reactions between a material and its environment that produce a deterioration, change of the materials and its properties. And the most common use of the word corrosion refers to the electrochemical oxidation of metals, with corrosion often producing oxides is as and or salts is as of the base metals. So we go to the first subchapter, the mechanism of corrosion. Most metal must have been produced from the refinement of ores, oxides of the metals that are found in the earth crust, and this refinement requires a great amount of applied energy work to extract the metal from their naturally occurring ores. In effect, this chemical separation results in a condition of increased chemical potential, defined as an increase in a thermodynamic function called the Gibbs free energy. The price of this energy expenditure during refining results in what may be considered a metallurgy trade-off. So oxidation is also referred to as the anodic reaction because the location is similar to that of the anode in a battery. The anode is where metal corrosion and weight loss occur. However, the oxidation reaction can only be sustained if the number m of electrons E left over from the oxidized corroded metal atom is m goes to mm plus blah blah and plus me can be consumed reduced at the cathode of the cell. Hence, the cathodic reaction is referred to as reduction. Corrosion and weight loss do not occur at the cathode, but the cathode needs the sustained current B from the reaction. So we go to the next subchapter is forms of corrosion. During the metal corrosion, the areas over which the anodic and cathodic reaction occur can vary greatly. This results in various forms of corrosion such as informed, attack, pitching, and crease corrosion. So uniform corrosion or generic corrosion is corrosion process exhibiting uniform telling the proceed without appreciable localized attack. It is the most common form of corrosion and may appear initially as a single penetration, but with thorough examination of the cross-section it becomes apparent that the base material has uniformly thinned. Uniform chemical attack of metals is the simplest form of corrosion, occurring in the atmosphere, in solution, and in soil. Frequently under normal surface conditions, excessive attack can occur when the environment has changed from that initially expected. Intergranular IG corrosion is the preferential solution of the anodic component, the granular boundary phase, or the zones immediately adjacent to them, usually with slight or negligible attack on the main body of the grains. The galvanic potential of the grains boundary areas of an alloy is analogous to that of the grains interiors due to difference of composition or structure. This difference may be due to the environmental interactions of metallurgical change in the grain boundary regions during manufacturing or surface exposure. So, pitting corrosion, pitting characterized by sharply defined holes, is one of the most insidious forms of corrosion. It can cause failure by perforation while producing only a small weight loss on the metal. Pitting normally occurs in the stationary environment. So in the intergranular IG corrosion is the preferential dissolution of anodic component, with the pitting corrosion is characterized by sharply defined holes. And the corrosion prevention or mitigation, although corrosion is a similarly pernicious process, it can be disrupted by breaking the oxidation reduction loop of an electrochemical cell. The difficulty is its complexity. For example, evaluating the corrosion exposure condition for metallic piping network requires an understanding of various fields conditions such as soil type, soil pH, stray current effect, and electrical continuity. Cathodic protection. The two types of cathodic protection are sacrificial anode protection and brass current protection. The prior example of zinc and iron in an exit is an example of cathodic protection with a sacrificial anode. The sacrificial anode protection is a simple method. A material that is anodic, then the metal to be protected becomes sacrificial. Anodic protection is based on the phenomenon of passivity. A limited number of metals, such as stainless steel, can achieve passivity. Anodic protection requires that the potential of the metal be controlled. Shifting the potential of the metal to the passive range can reduce the corrosion rate of an active passive metals. The anodic polarization of the metal results from the formation of the passive layer, which is relatively insoluble in the chemical environment. The most common use for anodic protection includes storage tanks, process reactors, heat exchangers, and transportation vessels. Anodic protection has been successfully employed in sulfuric acid environment to extend tank life, control of pH, and corrosion with the Purbach diagrams. Controlling pH is another way of lowering corrosion rates, and is a common practice in some applications, such as municipal and industrial water supplies. Metal can occupy various chemical states depending mainly on the pH of the environment and their electrochemical potential. So that is all my presentation. Thank you for watching my presentation. I'm really apologize when there is something miss or problem with my presentation or my language. So I will close with Om Shanti 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 Om. Assalamualaikum Warahmatullahi Wabarakatuh. Syallom, Namo Budaya, and see you in the next presentation.